You said that one more time, like, oh my god.
Oh my god, it's so hard.
Jonas, I'm gonna have you also for today, just for today. You don't need to look back. Yeah, I could tell. We're bringing in the monopoly.
And there's a
How do you know more about my Okay, folks.
So much easier.
So
I think therefore.
let's get the show on the road for today. Thank you for your patience. I hope you are getting to know your new partner if you didn't know them already. Who's sitting next to someone that they've already sat next to, just out of curiosity? Interesting. Like the shuffle is it shuffles, but I don't know. First, let's talk about the date. What do you think about today's date? It's pretty difficult, isn't it? It's tricky. So there's actually a video to help you with this problem that I prepared for you guys. Have you seen this before? Has anyone seen this?
No.
Okay. I really hope that you could hear this. Let's see if this is working now.
What do I do?
Just a minute. Let's see if this will work. Yeah.
I don't know what that is. Chicago.
Okay.
I thought you meant like, oh yeah.
Oh yeah, there's no sound. Okay, just a second. Oh yeah, it does have.
Like on Instagram, we got like these problems that are always like have like irrational solutions, but they do.
Nice.
All right, so we have.
Okay. Here we go. So he's gonna help us with this problem.
Like it'll be X squared.
-9. Very simple math problem. Watch this. 16. We know that is 4 squared. 9. That's 3 squared. What do we have here? A difference of squares. We're gonna factor that. 4 plus 3 times 4 minus.
So far, so good.
Yeah.
You enjoying this?
Yeah.
Okay, here we go.
Let's multiply that out. 4 and 4 is 16. 4 and -3 is -12. 3 and 4 is 12. And then we got 4, -3 is 4, that's 9. Perfect. Okay, we'll cancel these 12s out. That'll give us 16 minus 9. Perfect. Come over here. We're doing 16 minus 9. All right, 9 is bigger than 6. Let's get rid of the 1 here. That's going to give us 16 minus 9. And then we're up to here. And again, we get 16 minus 9. There we go. All right.
That's
we
the
have
best.
16.
That's the best. It's so good.
So
He was so close. He was so close. He had it. Had it right here. He had it right there. Anyway, I just had to share it with you guys. It's one of my favorite clips. For reasons that are probably obvious to all of you. But let's talk about the unit that we have in front of you. And let me share this. So chatty. My goodness. Okay, so it's a pretty short section. This is the last of the first 3 big units. So there will be a unit 4, but this is unit C. We're going to be talking about polar functions. And after we do this, you'll be officially finished with all of the AP Calculus material for those of you taking the exam. In fact, one of my students already took a practice AP pre-calculus exam over break, obviously, because, it's so much fun. And she got a 5 without studying, without even having this. So you're in a good place. You've been working hard and covering the material that will be on the exam. So if you're thinking about taking it, I do highly recommend taking it just if you think you'll enjoy it, and if you want that mark on your record. So you can see that it is a relatively short unit. We have 1 quiz and 1 test. Quiz is on day 3. So that day 3 where it says rates of changes in polar function, we're going to have a quiz that day. You can see that most of the homework is on Pearson, except for one on day 3, where I'll give you some handouts for that. Yes.
So wait, Mr. Newman, just if I like math is checking out, does that mean that after this, there's like a unit 4, but then is unit 4 like, how many like sub units do you have in this?
I don't think there would be any more subunits.
Oh,
I think we have 2 more tests, maybe a third one, and then the final.
oh, okay.
We're including.
So this test, one more test, and then the final, and maybe there'll be another test before the final. I'm not sure about the ultimate.
What's the
Count.
next unit?
Good question. I'm not sure. It's not AP calculus stuff, so it's extra things that we think you'll enjoy and would find beneficial. Derivatives are coming. Yeah, there'll be more limits for sure. Okay, warm-up time. Oh, the packet that you got is obviously an abbreviated packet. It's only the first 2 days. You'll be getting more next week. You're getting more, yeah. Kind of one by one. This is first 2 days, so. Do you like it? Okay, I'm glad you like it.
This is our.
Okay, so warm up. Oops, not that one. Warm up. Here we go. Yeah, let's bring these back. I'm so sorry about my writing here. Most of it, or much of it, is stylus.
Why is it like one paper?
Caleb, did you already download the pack?
Oh, I have it here. I should, yeah. I like do the pocket one here and I should do this one.
Oh, yeah.
Yes.
Oh, I can tell you the homework for this.
Basically.
I think.
No, Jensen. Oh, yeah. And then.
Yeah.
Just across.
Great. Wait, right? Plot it on X Y. Like a rectangle.
Well, first on a polar graph.
Three circles. Oh, I don't know. Wait, am I doing it right?
Oh.
Yeah.
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 I don't know how to draw it.
It's fun, yeah.
Just bring back good memories.
So pretty good. Oh.
Yeah.
Oh, okay, now I see what you're saying.
And then for the last one, let's
You
on.
have an option to make like regular.
Oh.
About ready?
Oh, you like the one from, oh, okay. Forgetting how to convert. Are you saying 45 minutes? But this is X. Wow. That's no, this is X, that's measured to it. That's what my data. Another minute.
That's what I was telling you. I said. Basically,
You need a little bit more time?
Yeah.
20 seconds.
Fire, sign up, fire, sign up, data.
Okay, folks. Let's go over it together. Number one, let's see, what is this point here called?
One.
What's the name of that point? The name of that point? Is it the origin? It's called the pole. If we're doing polar graphing, that's called the pole. And how many axes are there?
None. Infinite.
There's one axis called the polar axis, and that polar axis just kind of revolves around that pole. Yes? So what I'd like you to do is we're going to graph number one together on that whiteboard in front of you. With one hand, I want you to just pinch the pole, and the other hand, I want you to poke the number 3, comma, pi over 6. Poke it like this or wherever it is. So where is it with relation to you? So right, it's your whiteboard. That's just like right here, isn't it? Boom.
Yeah.
Okay, so I think that probably what you did was you imagined this. Oops, I need to go to here. That direction, yes. Did anyone mark a 3 on their horizontal axis? You could if you want, but should I just go straight up from there? No, I have to imagine a circle going through here. In fact, does somebody already make circles when you were doing these graphs? Right, so that's a nice polar graph, like lots of concentric circles. Okay, so we have that one. Let's do the same thing for number 2. Go ahead and pinch the pole. Show me where 2, comma, pi is. And we're looking for bam right here on the left side. So if I'm doing them all together, I would have something like this. And for number 3, principal, so we're -1 comma 5/4 is. That's in the which quadrant? In the first quadrant, right? Because 5/4 is in the third quadrant, in the other direction. So our 5/4 is this way. But those are all positive, which is why we have to go the opposite of that. So we go over here into that first quadrant. So right there. So I don't know, one would be here, one would be here, maybe. I don't know. Yeah. Okay. Moving on. Write another name, another polar name for each point in numbers 1 through 3. I'd like Nathan. What'd you get for a number 1? Another polar name.
I don't know if this is right, but I said -3 comma 7/5/6. I don't know if you do that.
Is that right?
That's what I got. Yeah, that's what I got.
You have a lot of support from your peers. I think that's a good sign. Yeah, nice. It's a -3 comma 7/6. Is that the only other name? How many other names are there? Infinitely many. Please don't write all of them. Okay, for number 2, Nathan, thank you for your help. Number 2, Connor can't help. He is not with us today, but here in spirit. Hello, Connor at home. Shiv.
No.
There's no Aram. Okay, that's fine.
I don't really know what to do with this about them.
Well, let's see. How about instead of pointing to the pi direction, we could point in a different direction?
Yeah.
Do you have some spontaneous idea, perhaps? Well, Shiv, let's do this together. You have a choice. You could either point in this direction, or you could point in this direction.
Yeah.
So whichever one you want to do. Which one do you want to do? This way? This way?
Yeah, sure.
Okay, what direction is this? In polar though. What the theta be here? No, the theta be here. Don't like here is pi/2. Yeah, so this is 0.
Yeah.
And that point that we're trying to hit over on the left, now we can get there by saying r is equal to what? It's a lot of pressure. In that direction is positive, but we want to go the other direction. That's why it is.
Right.
Right, this would be like 1, 2, 3, going that direction. We're going that direction. We want.
1.
Oh, maybe negative. -2, yeah. Oh, it almost had it. It's okay. Kind of. That's a lot of pressure. Thank you for that. Yeah, if we're going that direction, we just have to go to -2. C plus B space. I'm just kidding. I'm trying to make it good. Okay. Thank you, Shiv, for your help there. Oh, you again. Max, help us with number 3. Oh, I got 1, do we agree? Yeah. Shiv, what do you think? Does that make sense? Explain it. No need to explain. Any questions about these? Thank you, Max. Okay, I want you to rewrite the points in numbers 1 through 3 in rectangular form. Dun dun dun. Who's this gonna be? Oh, it's Augie. Help me out. Number 5, rectangular.
She did not get this one, but would you work for this together?
Sure. Okay, so we're doing this point, right?
Yeah. Oh.
That's a good place to start. So if I want the x value, that means I'm going to do something like this to get that x value, which I don't know what it is. And maybe, I don't know, maybe I'll make a triangle there. How do I get the x and y values of that triangle?
I think I remember.
Okay.
You know
If
that-
only I had a lot of time earlier to do this, guys.
Well, I was stuck on the first part.
I see. Oh, interesting.
So we can figure it out because it's like sine of to get the x value or the y value.
Yes.
Or both of them?
Both of them.
First, if we wanna start with the y value,
Okay.
we can take sine of pi over six,
Ah, okay.
and then multiply that by the, hypotenuse, which is r. So
Nice. Okay, so
radius Sine of pi over six.
I like
equals
that.
pi. And then
Okay.
x is equal to, radius.
Oh,
times-
X is, well, can you finish this one? What is sine of 5 or 6?
Oh, sine of pi over six. Oh, yeah.
Yes. Yeah, there you go.
Yeah, so it's 1/2 to, yeah.
It's 1/2.
And then three, yeah, so then we have, here the two,
Nice. Okay, so for the X, it's gonna be X is equal to,
then we got cosine of 5/6,
so interesting that you start with the cosine, but okay.
and then, we can't multiply by three, right?
Okay, yeah,
And then cosine of 5/6 is equal to root 3/2.
nice.
So then 3 times root 3/2, so 3 times over, 3 times root 3/2 is the other side.
Thank you very much. So we got 3 root 3 over 2, comma 3 over 2. Thank you, Augie, for that. Any questions?
And then it explained it better myself.
That's high praise. You're pretty good at explaining things.
Really?
Yeah.
That's high praise.
Wow. Oh, no, that's so nice. Thank you. Does anyone have a different way to do this? Get the X and Y coordinates here? Yes, Nia? Less efficient? Well, yeah, so if we had the triangle, how would you go from there? Okay. Ooh, okay. Okay. So how's that gonna help us here? You mean opposite from 30 degrees, right? Then before you move on, does that make sense? The short leg is just half the hypotenuse?
Yes.
There we go. And then what? Uh-huh. Yeah, we just take that other leg, the short leg, and multiply it by square root of 3. I highly recommend that method. If it's a special triangle in there, use it. Highly, highly recommended instead of the formula. Formula works. As you see, Augie got through it. It's perfect. But I really like the use of the 36 and 90 triangle. Right, you spend so much time on it in geometry, keep using it. It comes in handy. Thank you for sharing that with us. And you get the exact same thing. The next one, rectangular for number 2, L. This is a toughie. For number 2. When you say the same way, what do you mean?
I found the angle.
Okay.
The theta times R and sine theta.
And you got -2 comma 0. Okay, thank you. Nice.
One.
So R, yeah, okay, so perfect. Any questions? Is it possible to just look at it and say, hey, that's -2 comma 0? Or that, but yeah, if it works, right? The formula works. So you have lots of tools at your disposal. It's up to you which one you choose. Your choice. Choose wisely. Number 3. Number 3. Emma, help me out here. My voice is cracking. This is we're in number 5 for doing the third. Thank you for paying attention. For the third point. Okay.
Radius of 1 times cosine of pi over 4.
Oh, so you use the renaming one. Okay.
So I got negative root 2 over 2.
Okay, be careful. If you're gonna use pi over 4, you have to use 1. If you're gonna use 5 pi over 4, then use -1. You can't use 5 over 4 and -1.
1.
Okay.
That would be root 2 over 2.
Root 2 over 2. Okay.
Y equals the 1 times sine of pi over 4 He's also the two.
Nice. So we get root 2 over 2, comma root 2 over 2. Thank you. Is there another way to do that? Nia for 300. There's a triangle we could use there? Oh, look at that. There is a triangle. What kind of triangle is that? 45, 45, 45, 90. Thank you. What's another way to do this? Now, if you know, let me know. Can we use a unit circle for that? What's the radius of the unit circle? Isn't that appropriate for this problem? And at pi over 4, the coordinates are negative?
I would forward to coordinate their negative.
5 pi over 4.
We're over here. We're over here. We're into the rename one. A simple one. Yeah. Root 2 over 2, comma root 2 over 2. Many tools at your disposal. Up to you which one to choose. Whew. Okay, this is taking like the whole period. Polar to rectangular, which means I want x in terms of r and theta. I think we already talked about this, didn't we? When we were doing this last problem, we said x is equal to r cosine theta. Have you ironed this into your brain? Okay, and as well, y is equal to r sine theta. Yay. For rectangular polar, that means I want r in terms of x and y. So I need some help from the one and only Lee. One and only Lee. Well, I want x's and y's. So maybe did you start with r squared equals x squared plus y squared? Okay. Then from that, we know that r is equal to, as you said, the square root of x squared plus y squared. Thank you for not saying that's just x plus y, because that would just be wrong. Are we good with that? Yes, Jonas? Oh yeah, we're not done. It's just r first. Yeah, just r first. We're not quite done because r should be equal to plus or minus, which makes perfect sense considering polar coordinates, doesn't it? R could be positive or negative. It's up to you to choose which one is appropriate. Thank you, Jonas, for telling us what we had to do to finish this. We need to do theta. I'd like some help from the one and only Leah. Right.
Fine. R theta is y.
You said arctan of theta? Arctan of theta equals what?
Y.
Equals y over x. Where did this come from?
Like tan is y.
So where did the r come from? But I agree with you, 10. What's that?
Radius.
Well, whenever I'm confused in a math problem, I just kind of break it down to what I need. So I say we have this point here. If we're going from rectangular to polar, that means I have an x and a y value, correct? And if I want the r, just as Lee already said, we have Pythagorean theorem right there, but I want to get theta. So the thing that binds theta to x and y, and you nailed it, is what binds these three together? Tangent. So isn't it just tangent theta equals y over x? Yes? Looks familiar? Bless you. Sometimes I sneeze when I get excited about math too. Or we could change this to theta equals. How do we solve for that theta? Yeah, Augie. Tan inverse of yx. Would you please show me which quadrants tan inverse lives in? Would you please show me the quadrants?
Oh.
Quadrant 1 and 4. And you can show me like this too. Would that make sense? Or like this side. That's where tan inverse lives. Okay, thank you, everybody. That was quite a doozy of a warm-up. That was like a burn-up, wasn't it? It was a long warm-up. I didn't intend for it to be that long, but I hope it felt good. Get back in the swing of things. Definitely warm me out. Whew. Yeah, Matt, you okay? Need some water?
I think all the spring break non-math ones.
Oh, nice. Okay, good. We cleared the cobwebs.
Yeah.
Let's get to the packet. No more rust. Rust be gone.
No, I don't.
Okay, this is not really necessary, but I think it's just an interesting part. This shows us the difference between a city that is based on rectangular as opposed to cities that have polar layouts, right? Right? It's kind of cool. The top one is a little slice of Paris. It is, yeah, a little slice of Paris. It's not all of France, but it's in Paris. And the bottom one is a little slice of Mexico City. New York. And this one on the left is New York.
Fox River Penitentiary, ever seen,
Oh.
Yes. Oh, interesting. Okay, so you can see to go from one point to another one here, it would make sense to like talk about horizontal and vertical distances, right? Like a grid. As opposed to if you're in Paris, if you're at the center there, then you find a direction and you go in that direction, just like a polar grid. So you have to know math.
Oh my.
They'll say, yeah, go to 2 pi over 3. I don't think they say that. I think they probably say go down street, or something like that. Oh, it's so rectangular, but then it like, it's like downtown technically, but it's not a perfect grid, obviously. Okay, today we're talking about polar functions. We're talking about polar points, and this is one of my favorite topics. So I think hopefully you enjoy this. I'll try to give you as much love as I feel for it. So polar functions, we're going to start as simple as possible. If we're looking for all points that have r is equal to 4, could you imagine where all those points would be? What shape would it make? Make a circle, and what do you know about that circle?
Radius.
Has a radius of 4. So I'm going to draw that in red because I can. So I'm going to go 1, 2, 3, 4, and I have like this point, and this is definitely going to come out a little wobbly. My stylus is just acting up. There we go. R equals 4. Yeah. Okay, so that's our first polar equation. Isn't it cute?
Yeah.
I agree with you. Our next equation is theta equals pi over 3, which is just all points that have theta equals pi over 3. Do you see where that would be? It's a line. Specifically the line, can you show what it looks like? Along pi over 3, all the points along that line. So we'll go up that way. Just positive? Yeah, exactly. These negative R values, we can't leave them out. That'd be sad. Yeah, we're not going to do that. This is an inclusive class. Okay, so there we go. Our two first polar equations. And I'm going to take a look at these a little differently. But instead of having a polar, I'm going to convert that to rectangular. To do this, my first step is to square both sides. Uh-oh, I forgot something. What did I what? Because look at where is the diagonal line? It's on the axis pi over 3. And that's theta is equal to pi over 3. Now let me just pin this down so it doesn't move anymore. Set as background picture. Okay. That's always a drag. Okay, so back to this r equals 4. I'm going to square both sides, so get r squared equals 8. And if we remember back to, I think, was it Max who told? No, I forgot. Someone very, very smart told us that r squared is equal to x squared plus y squared equals 4. Does this equation look familiar to you? Oh, I'm sorry, equals, I forgot to square both sides, didn't I? 16, excuse me. Does that equation look familiar to you? It's the equation of a circle, radius 4. Right? Does that look familiar from your algebra classes? That format? Great, yeah. So you can see that actually in polar form, it's so much more eloquent, isn't it? It's r equals 4. Tell us what it is. The circle radius 4. Okay. Theta equals pi over 3. We remember that theta is equal to 10 inverse, as Leah was reading us, leading us to. Pi over 3. So this would be just converting from polar to rectangular. If I want to get rid of that tan inverse, what can I do to both sides? Take the tangent of both sides. So leaving us with xy is equal to tangent of pi over 3. Do we know what the tangent of pi over 3 is?
Yeah.
Really?
Yeah.
Yeah, it is. So close to that. It's root 3, which means y is equal to root 3 times x. So, and there in rectangular form, we recognize that that is the shape of a line that passes through the origin, right? With a slope of root 3, which is exactly the line we obviously drew. You can see that as we did it, it's much, I think in polar it's much easier than the other one. Although in rectangular it's not so difficult. Any questions? The answer is yes. Convert to rectangular form, then identify the shape and graph each equation on the same grid. Okay, for A, I do that r cosine theta section. Is that x? Is that true? X is equal to r cosine theta? So I could just rewrite this as x equals -2. Show me what this line looks like. And I gave it away. It is a line, and it is a vertical line going through the x-axis at -2. So now suddenly we're looking at this in terms of rectangular instead of polar. There we go. So this is, and I'll label this as r cosine theta equals -2. For B, how can I change that to rectangle? It's a trick. Sine theta is nice, but wouldn't it be nice? Like this is our dream. Wouldn't it be nice if we had r sine theta? What's that? Could we? Could we have an r there? Yeah, you all took algebra, right? I hope. If we want an r on the right, all we have to do is multiply both sides by r. That gives us r squared is equal to -6r sine theta. I'm gonna give you a minute to continue converting this to rectangular. I think you know what to do with that r squared. Check and sure your neighbors go on with this. And put it in a recognizable form. I do want to hear 3 words. On the left side, r squared becomes x squared plus y squared. You did that. Right side becomes -6y. So we successfully converted to rectangular, but it's not recognizable. Not really. What should I do? Yeah, I'll get it. I'm not gonna plug in 8 points, so I want to change the form until it's recognizable. But you're right, we could plug stuff in if we wanted to get some points. I'm gonna move that -6y squared, right? I don't want that over there. So I need to do x squared plus y squared plus 6y equals 0. Why not do that? What are the 3 words I want to hear? Complete this. Oh yes, your dream has officially come true. Y squared equals x plus y squared. This is the first one. And this is what? This working out. Y equals r. from the conversions. Are you successfully completing a square? Let's talk about the process. What do you do with that 6?
Divided by 2.
Divided by 2, so we get 3 and then square it, so we're gonna add 9 to both sides. What kind of a trinomial is this now called? It's a perfect square trinomial, so we can rewrite it as x squared plus y plus 3, quantity squared equals 9. So let's think what this is. It's a circle, radius 3. But what is that? Y plus 3 there?
That's like what's some.
It moves it down, right? It's inside the function, so it's the opposite to what you think. So we weren't able to do this quite easily as the other ones, but we were able to get the information. Like here's the center, 1, 2, 3. I'll do this in blue. And I'll do this in red. There's the center. And then go up, down, approximate left and right. And there we go. Okay. Oh, good question. Who knows? Who knows? But time will reveal all. Yes. Is there a way to find the point there? Oh, find the points of intersection of these two things? Yes. Well, without a calculator, maybe it depends on the equations. That's not what we're doing. We're just graphing functions for now. I really like that idea of finding points of intersection because they definitely exist here. Can we move on? I have some blank paper if you needed it. I'd prefer that you had it, but I just have some extra stuff. We're about to go off the notes. I'm not using the needs. Oh, that.
Yeah.
Of course.
Anyone else? What do you want? Going off the notes right now. Okay. Here we go. Switch to the doc cam. I'm gonna take this off. Thank you for giving it a pretty here. Yes, it is Pierce. Oops. Hello. Oh, it's. Sorry. But you can come and say hello if you want. Yeah. Okay, so I really want to be able to do this with the people at home. So I need to be seen. So right now it's recording this where I can't see normally. Okay, so what we're gonna do now is graph some polar functions in a completely different way than we were just doing. We're gonna use something called a helper graph. So if we start with something like r equals 2. I'm gonna graph this 2 different ways. I'm gonna graph it in a rectangular grid. And this will make more sense in a second. It's a little bit weird. But this is no longer the x-axis, this is the theta axis, and this is the r-axis. I'm gonna graph it in a rectangular fashion. Which means my input theta is gonna just kind of go along here. And for all those inputs, the output is just 2. So we're just gonna leave what shape? Could be a horizontal line, because we're on a rectangular grid. So all this information here, r is equal to 2. It goes off in that direction. And I'm going to split this up since we have theta. I'm going to split that up write a 2 pi over there, and split that up into how many pieces? 4, because there are 4 quadrants. Pi over 2. 3 pi over 2. I can zoom in a little bit for you guys. Okay, super easy so far, I hope.
Yeah.
I'm gonna transfer this to polar. You already know what this looks like, don't you?
Sign.
You already know what it looks like.
What's that?
It looks like a sine graph.
Nope.
Okay, so what I'm gonna do now is analyze bit by bit. So Jonas, you're gonna wanna pay attention to this. As will everyone else. So when you're here, go ahead and put your pencils down. Okay, this first quadrant, 0 to pi over 2, is just from this to this, 0 to pi over 2. So what I'm gonna do is I'm gonna fix a distance, and I say that this is 2, and say that from 0 to pi over 2, this is what our function looks like, the polar graph. Does that make sense? And then from pi over 2, pi over 2 to pi, we take that 2 and continue, leaving us with something that looks like, which I think you already knew. The circle, yes, this is 2. What is this right here? -2.
Two.
It's also 2. This is 2, which is trippy, isn't it? It's a polar graph, right? This is a polar graph. So remember, I'm just gonna stay here at 2. Keep going at 2 after pi. From pi to 3 pi over 2, I still stay at 2. And 3 pi over 2 to 2 pi, I here at 2. So leaving us with a circle of radius 2. Surprise. Let's turn this up a notch, shall we? You ready for this?
Yes.
I didn't hear you. You ready for this?
Yes.
Don't talk. Okay, we're gonna start with our sign data. You have your pocket sign reps.
Oh my gosh.
You have your pocket sign rep. Thank someone has hers. I appreciate that. It might be I have that's what right what's this left hand down. So I'm gonna do first a helper graph on a rectangular grid going at 2 pi. How many points do I have to graph here?
2, 4.
Let's start with 2, 4, 6, 8. Which one should we graph?
Oh.
4?
No.
How many points do I want on your sign graph?
5.
5. Because split into 4 sections, I want that first one here. Here. Lovely. Oh, I am in love with my sign graph. It's so nice. Don't you agree? Super nice. Thanks, Ready? Like her. Okay, ready for the fun?
Yeah.
I don't know if you can handle this much fun. You ready for this? I'm ready for this.
Your
I was
favorite
born
type
ready.
of rap.
Parabola.
Parabola.
Sorry.
No, he likes the.
I love it. I'm saying my favorite child.
Is there hope?
Okay, pencils down.
When can I get to there?
Yeah, what's your ear pencil? Okay, so let's take a look at the first quadrant, which is we're going from 0 to
I have 2.
pi over 2. In that quadrant, the radii are increasing from, according to my helper graphic, that radii are increasing from 0 to 4. Right? If it stayed at 4, right? If it started at 4, I'm going to hold the pole right here. If it started at 4 and stayed at 4, it's this. But it's starting at 0 and increasing to 4, which means, watch the tip of my finger, it's going to trace this on my grid. Again, it's going to go from 0 up to 4. So instead of like sliding along here, 0 to 4, it's going to turn 0 to 4, which means I'm tracing what looks like something like this. I'm going to put a 4 right here. Something like that.
Oh my god.
Right, as I open up 0 to 4, doesn't it trace that? Is that exactly what this is saying in the first quadrant to do? Let's see if you could do pi over 2 to pi.
Oh, is it? Yeah.
We're now on parentheses first. Oh, like that. So the next quadrant. Pi over 2 to pi, what happens with the radii?
4 to 0.
It starts at 4 and closes to 0, but it turns. Right, so we had this, and now we're gonna close it up. So it's something like this. But think about what happens in the next quadrant. Going
Negative
this.
4.
Discuss.
Is it gonna be like? Gonna make a second circle below. Gonna make a filter shape, yeah. Oh, wait, there's no negative. Oh, but it's just for peace. Wait, where's
Oh, wait, but you could also put it down. Oh, yeah, there's no
So, in the next quadrant, what's happened with the R's? They're all negative, aren't they? Which means anything in the third quadrant will appear
First one.
in the first
Yeah.
quadrant. So it's the same thing. So when we go from pi to 3 pi over 2, it's going to open from 0 to -4. You see that happening? 0, tracing what we've already done. 0 to -4.
But that's actually up.
It's up here. And the next quadrant, 3 pi over 2 to 2 pi, it's going to go from that -4 down to 0. Exactly tracing what we've already done. What do you think?
Why can't it be negative?
Well, it is negative. It's just negative. Positive is this direction. But all these radii are negative, so we're not going to see it in this quadrant. We're going to see it going out the back of that theta. And this is the theta from pi to 3 pi over 3 pi. Negative. So let's just trace it from 0 to 4 to 0, yes, to -4 to 0. Do you see that? It's exactly that information. Yeah. In a polar sense. So let's take a moment to convert this algebraically to rectangular. Do that. Take a moment to convert that to rectangular. Check with your neighbor, especially if you're stuck, check with your neighbor. You're converting this to rectangular, because right now it's polar. So I want to see the difference of x and y. What did you do to both sides first? What did you do to both? The square on both sides won't help, unfortunately. We need just an r over here, so you're gonna multiply both sides by r. R squared equals 4r sine theta. 4y. Oh, that's true, right? Okay, folks. R squared changes into x.
x squared plus y squared. R sine theta changes into y. And then next step.
And these
Subtract that 4y with a big x squared plus y squared minus 4y equals 0. What three words do I want to hear? I want to hear I love this. As you complete the square by adding what to both sides? So cheesy. Okay, leaving us with x squared plus y minus 2 squared equals 4. And from this, does that connect to what we already graphed here? Yeah. You recognize that this is a circle, radius is 2, where the center is at 0, 2. It was 0, 0, but it moved up 2. Doesn't it all fit together? I hope. Any questions?
Yeah.
Okay. So, perhaps your question is, can we try another? That's what it was, wasn't it? Good choice. Can you please try r equals 6 cosine theta? And don't convert this algebraic thing. I want you to use a helper graph, and I want you to convert that information to polar. I want you to analyze it quadrant by quadrant. How many points do I want on your cosine graph? 5, yes. Can you show me your pocket cosine, please? Pocket cosine. Cosine's right here. The shaka. Pocket cosine. This one is trickier. Poor Connor must be like this. Missy Connor. You know you're whipping on time too. Maybe. One quadrant at a time. After you do the first quadrant, make sure to check in with your neighbor. That's I caught. That is a W. That's right.
By the time you get to it should be good.
I understand why it's not people don't talk about each other. Like, why doesn't it go together?
In 10 seconds, let's discuss the first quadrant. Okay, folks. Your attention, please. I'm sorry to interrupt your discussion.
But it's not, it's like not talking about
The first quadrant, all the information is right here, isn't it?
It's not a snowman.
All the information is right here. Where it tells us that the radii are going from 6 to 0. Now, if it's started at 6 and stayed at 6, it would do this, wouldn't it? It would do this. Yeah. But this is starting at 6 and going to 0. So what's that called? Did you get that? Starts at 6 and goes to 0. Please continue. Starts at 6. Goes to 0. It starts at 6. Doesn't stay at 6. Goes to 0. So,
And then so this is zero, so it just goes in. Okay. Yeah. Okay. So then.
Oh, because you're.
Why? So for this one, it starts at 0, right? It would start from here and then it goes up to 6. I mean, 4, sorry. Yeah. And then for here, it goes 4 to 0. So it goes back to that. Okay. And then for the other part,
Now this is.
it's just.
Okay, folks. These two finished a long time ago, so we gotta move on. Let's talk about the next quadrant. 5/2 to 5. What's happening there? The radii are going from
0 to 6.
0 to -6. Now, the fact that they're all negative means we're gonna see stuff in the second quadrant.
No, fourth quadrant.
It's gonna present in the fourth quadrant. It's always opposite to that. So as we go from pi/2 to pi, the radii are gonna be here ending at 6 negative pi. Sorry, -6 pi. Right, -6. The r is -6, the pi is, the theta is pi. So it's coming out this direction. Bam. After that, in the third quadrant, the radii are going from -6 to 0. You see that? -6 to 0. And then in the last quadrant, 0 to 6. Just retraces itself up. So that's it. We're done with this one. You recognize what shape that is? Circle. Radius 3. I'm not gonna ask you to change. We'll break that into rectangular. Any questions? Yes, Oliver.
Why doesn't it go into the left side?
The left side of the y-axis. Over here? Yeah. Well, like here, if we're in the second quadrant, we would need some positive ones, wouldn't we?
Yeah.
Second quadrant, that's all negative. All those being negative. We're pointing in that direction, we have to go this way, out the back, because those are all negative all. Right, the negative ones are the screwy ones, I know. Keep letting it marinate. We have one more problem to do, and before that, I have a shameless plug for you guys.
Shameless one.
Shameless plug, do you know what that is?
Yeah.
I'm going to promote my own self-interest. On Friday, I'm going to be teaching a surprise dance class during lunch. No, I'm not free. Wait, I'm going to teach you a surprise dance class on Friday. Just the first half, If you're free, I would love for you to join. It's a beginner class. It's gonna be the first half of
Wait, I
lunch in
can't
the
dance, but I
quad.
like to think I can.
So it's for non-dancers, dancers alike. If you pick
Yeah,
it.
that's.
Oh,
that's
that's
it.
Are gonna move back to the packet.
How is it?
Hello.
Yeah.
Oh, I guess I should do this.
Like more than secure now.
Yeah.
Please go to number 5, I think it is in the packet.
I'm Jason.
Yeah, number 5.
Okay, we're running really low on time. Thank you for your patience. What's happened to this cosine here? Shifted up 4. Let's do this so that each one of these is 2, 2, 4. So at 4 is going to be the what of this cosine? The midline, thank you. Either the midline or called the sinusoidal axis. And how many points do I want?
Five.
I want 5 of them. And let's say that this is pi over 2, just to give us some space. It should fit perfectly. So here's our helper graph. We're doing rectangular first. But this is still the theta axis and the r axis in a rectangular sense. Yes?
But does E work? That's. It's reduced the to five.
Oh, if it were 4, if that were inside with the theta. But there's no horizontal stretch. Yeah. But there's an amplitude at 4, that vertical stretch. Thank you. So take it 1 quadrant at a time, and let's see what you can get. It's a shape you haven't seen before in a math class. It's not a snowman. My graph is so wrong. Sorry, folks. Thank you, Judy. But yeah, that's what it is. First quadrant, the R's are going from 8 to 4. Can you show me what that looks like with your own personal little turny thing? From 8 to 4. From 8 to 4. You're not closing up. Don't pinch. There's no 0. 8 to 4. Do it. We're going to start here and end here. Let me do this in red so you can see it more clearly. Right? Aren't those points key? No, zero is key. Oh. Now this is nice because you notice there's no negativity going on. Keep thinking. 8 to 4. 8 to 4. 8 to 4. That's such polar apple. 8 to 4. I think try the arm. Yeah, it is part. I just Yes.
It's hard.
That's more than
Which maybe you're pretty instructive.
So, wait, is it a heart?
It could be a loaf of bread.
Oh, loaf of bread, perhaps.
I know that.
Oh, that's.
Yeah, just like a. Yeah.
Stop ignoring that there's a friend sleep right that's so.
In the second quadrant,
5 to 5.
the R's are going from
4 to 0.
4 to 0. We've done that before, haven't we? Gone from 4 to 0. So something like this.
What's the outside?
No, that's
Oh, is that really like that?
5 or 2 to 5
Oh.
or to 0.
A little past.
The next quadrant goes from 0 to, is it 0 to 4? It opens up like this. That's positive, and we're going from 5 to 2. The last quadrant, we're opening from 4 to 8.
Round with individual points.
You could, yeah, you could. But it's good to know where everything comes from. It. I want to take one last look at this.
Glitter color?
Okay, look at this, the axis I have. I want you to notice right now the R is 8, right? The R is 8, isn't it?
Yeah.
And now it's going down to 4, just like in the helper graph. And as I continue to pi, what's happening with R's?
Going down.
Really look at that. You see that it's going from 4. You see that intersection with the red? It's going from 4 to 0. And then as I continue to 3 pi over 2, the R is now increased to 4. After 3 pi over 2, it continues opening up to 8. What do you think about the polar graphs?
But very interesting.
Very different. Okay, I hope so. We'll continue this next time. Have a great day, folks. Great job today. Oh, just a minute. Let me close this out.
Good job.